Welcome to day 52 of our graphics and multimedia course. Today we dive into the fundamentals of lighting and texturing, two powerful techniques that bring depth, realism, and artistry to 3D graphics. Let's begin with what we will explore today. We will understand different lighting types used in 3D graphics, delve into material properties and shading models, and examine how textures enhance surface detail. We will also learn how lighting and texturing work together to create realism, and finally, we will apply our knowledge to a hands on mini project. Lighting is one of the most important aspects of 3D rendering. It adds depth, mood, and realism to our scenes. Proper lighting controls how our textures and materials are perceived and directs attention to focal points in our design. Here we see the most commonly used light types in 3D graphics. Point lights radiate in all directions like a light bulb. Directional lights mimic sunlight with parallel rays. Spotlights create focused beams useful for dramatic effects. Ambient lights fill a scene uniformly, and areas lights simulate realistic soft shadows, such as from windows. Choosing the right type of light dramatically affects the mood and clarity of our scene. Materials define how surfaces react to light. Diffuse properties give us the color base. Specular reflections create highlights. Ambient properties show how surfaces look in shadows. We can also manipulate opacity and reflectivity. Shading models like flat, foreground, and fong control how smooth and realistic our lighting transitions appear. Texturing simulates surface detail without adding complex geometry. We use various maps. Diffuse maps provide color, bump, and normal maps add surface irregularities, and specular and displacement maps affect shine and surface depth. With this, we can make a flat surface look convincingly bumpy or reflective. To apply a texture correctly, we unwrap our 3D object into a 2D plane, a process called UV mapping. This ensures our textures align properly, but if not handled carefully, it can lead to stretching or bleeding issues. Accurate UV mapping is essential for professional results. Lighting and texturing are deeply connected. Light helps us the fine details that textures provide, while textures react to lighting for realistic effects. When used together with proper settings, especially in physical based rendering workflows, we achieve lifelike scenes with visual impact. Let's put this into practice. We will build a 3D scene using at least three different types of light and apply textures to three distinct objects. By combining shadows, lighting, and texture maps, we aim to create a visually balanced and natural looking composition. Tools like Blender or Maya are perfect for this. To deepen our understanding, we can explore Blender Guru's tutorial on lighting and texturing, Pixar's Renderman documentation, CG Cookies codes on surface materials, and real-world texturing examples on forums like Polycount. Let's recap. Today we learned how different lights affect a scene, how material properties define surface behavior, and how texture maps add realism without extra geometry. We also saw how combining lighting and texturing creates rich visual effects. Our mini project gave us a chance to apply these concepts creatively. Great job today. As we wrap up, let's keep experimenting with how light and texture shape our 3D designs. Up next, we will explore the principles of 3D animation, where motion brings our creations to life. Thank you for your attention.